All right. Let's try this one more time. PowerPoint started. All right, we're going to talk about if statements, also known as branching, according to Zybooks. You do tomorrow have the test due and the discussion post due. And if you didn't do the reading last week, it's due. Just making that clear, because we had some discussion about it earlier. The project, however, is not due till Friday because I missed a day of class and giving y'all some extra time to send me emails. So project's due Friday. Everything else is due Tuesday. Questions? Okay, good. I like it when there's no questions. All right, so we have done function calls. We know how to use methods or functions. You know how to write them. You can create your own. Nobody's used more than one main function in their project, right? One main, just one. Just yeah. You don't have to admit you did it, but if you did, go fix it. We've used loops. We know how to use for loops. We are going to learn a second type of loop, but we're going to do it coming up. We'll use it in conjunction with the if statements. Conditional statements execute when something is true. So a condition has to be met. We call these if statements or if else statements. Right? We also the next type of loop we use is a conditional loop. We're going to use a while loop, but that's the next chapter. So the good thing about while loops is you won't have any additional reading because our book put both loops together. So then when we do while loops, you don't have to do any reading if you finish the reading already. You might want to go back and look at it, but you don't have to. So we have some examples. And these are really old examples. Don't laugh at my examples. Just go with it. I don't want to change my slides. I will one day. I will. So this is where I need you guys to use your brains a little bit. This is logic. We're going to have to play with what we call Boolean logic. And Boolean's a fancy word for true or false. The data type in the computer, a Boolean, means it's either on or off, true or false. It's stored as a 1 or a 0. And now here's your trivia night information. If you ever see the symbol 0 with a line in it, and marker. Where's a marker? Here's a marker. So you all are used to seeing this is like a power button. That's actually shorthand for 0 and 1. Because if you ever see a toggle switch, it has a 0 and a 1 on it. In old time computer science, 1 meant on, 0 meant off, because it's throwback to electricity and circuits. And 1 indicated that there was power running through a circuit. 0 indicated that there was no power running through a circuit. So there's your trivia answer if you ever get asked a question about what the 1 and the 0 on your computer switch is, or what this symbol means. You can now. Okay, I do a lot of geeky trivia. Don't ask me a sports question. No sports trivia. All right. So in our example here, you buy an iPhone X if you have more than $1,000. Otherwise, you go to Microsoft Lumia for free. For those of you who aren't aware, Microsoft made some really bad cell phones for a while. So if you have the correct amount of money, you need to buy an iPhone. Otherwise, you get the free phone. So in English, it's in the next state, right? Only one of these two things is going to happen. Not both. You're not getting an iPhone and a free phone. You get one or the other based on the test of how much money you have. if I was coding this, it looks something like this. I would define a function by phone. It's going to take an input of the amount of money we have available, right? This is a fancy comment when it has 3 quotation marks around it. It just makes it a comment. The docstring comment. So this function is going to determine and return what the phone is based on money. From here on out, I'm going to start asking y'all to write docstring comments. 1 line per function, minimum, even more. But the great thing about these is you don't have to start, once you start the comment, you can do multiple lines without having to put the comment symbol in front of each line. You start it with 3 and you end it with 3. It could be a paragraph. It could be 3 pages long, as long as you start and end it with this. So why am I doing this? Because when you get to CS1, they actually require it. They require you to do comments in a very, very specific way. I'm just trying to get you in the habit of writing them to begin with. They're going to make you do it in a much more formatted way. You're going to have a description. You're going to talk about each of the parameters. You're going to talk about each of the return types and all that stuff. We're not going quite to that length in here. I just want to get you in the habit of, oh, I need to make sure I commented my function. It's a good habit. I'm trying to teach you good habits and not bad habits. And it generally doesn't go inside the function. It generally goes right above it. But so I'm going to ask you to get in the habit of right before the definition. Tell me what it's going to do. I'll fix my slides one day. So if statements are very much look like your fors. So your loops, they're going to start with the keyword if. The end of the line is going to have a colon at the end, and it's going to have the condition to be met on that line. Do we have more than one condition? Yes, I will be teaching you how to do that. So the condition always evaluates to true or false. So you'll see a lot of greater than, less than, and equal to's because those evaluate to true or false in the computer. So if my money available is greater than 1,000, I'll get a true return when the computer does the math on that. And if it's true, it does anything indented. Indentations are going to be vastly important on these. Else, if this is not true, it jumps down to the else. It skips the indented lines and does anything indented under the else. If true, do this. Else, do this. Got 1 thumbs up. It's Monday morning. Y'all all still asleep, aren't you? Okay. I got more feedback on that statement than I did all of this. All right. So once it's done all of this, if else, it will then jump down and continue with the code. In this case, it will return what type of phone you're getting. So here's another example. Here's a grade book example. You all are familiar with grades, right? Yeah. So if we want to determine if the student's grade, what their letter grade is based on their numeric grade, we could use a series of if-else statements to block it off into ranges. If it's above a 90, you get an A. If it's 80 to 89, you get a B. If it's 70 to 79, you get a C, and so on. If it's under 60, if it's 59 or less, you get an A. Right? To me, this is the harder part of computer science. I can teach anybody how to put code together or copy code. But teaching you how to think through the logic is the hardest part. So you figuring out what structure and logical units you need is harder to teach than just code. So when I say we're going to do computational thinking, this is computational thinking. So that translated into a much longer piece of code, right? So what we have here is we have an if statement followed by an else if, and because computer scientists are lazy, the Python people thought it was just too much trouble to type the extra 2 letters to spell out else. So it will be ELIF. Don't ask me, just go with it. Java actually spells out else if. All right, yeah. So, and if for the first one, ELIF, if you have a second or more test. If you have a bucket that's going to just hold everything that fails a test, that can just be else. So 59 and below, you can just do else. You don't have to test for 59 because you tested for all the other possible. Could you put an else if down there? Absolutely. But this saves the computer one logical operation, which is nanoseconds, and doesn't really mean a lot if you're doing 40 grades. But if you were doing 40 million grades, that nanosecond would potentially make your program run faster or slower. So you cannot have an else if or an else without an if. You can have an if without the other two. So you could have it test for something, and because there's not an action, if it fails, you would just leave it on. Now, if I just needed to know if you made an A and it didn't care about anything else, I could leave the rest of it off. Have I confused anybody yet? So another example, I do ifs by example because they seem to be clearer to you guys if I use by examples. If you have a 60% chance of rain, you need to bring an umbrella. If it's less than 60%, I'm going to risk it and not take an umbrella. Let's be honest. I'm never going to remember to get my umbrella out of the car unless it's 100% chance of rain and it's actually falling on me. So if rain chance is greater than 60, bring my umbrella, else leave it at home. Or in my case, always leave it in the car because I never have it when I need it. You don't need the else part, right? Because you don't have to explicitly tell yourself to leave your umbrella somewhere. So in code, you just need to tell the person or the user to grab their umbrella. It's implied that they're going to leave it at home, so you don't need the else portion. That makes sense? Like on your notifications on your phone, it only notifies you when you have an appointment. It doesn't notify you when you don't have an appointment. Or it notifies you have a missed call. It doesn't notify you if you have no missed calls. Yeah, that's what for it to notify you. No one has called you in 460 days or something. That would be awfully depressing. My sons have informed me that nobody calls on a cell phone anymore. It's all text messages or phone. I love phone. Instagram. I don't like calls. Me too. I'm a video phone. I'm personally am a call person because I can say what I want to say much faster than I can type it. Yeah, he doesn't either. So
I did that one side.
we're going to.
This is for long distance.
Okay. We're going to start writing our own if statements, right? It's kind of a control structure. If statements control the flow of the program. If loops control things, if statements control things, they're controlling the actions of your program. So you'll see the term control structure moving forward. When you get into higher level, when you get into Python, CS1, CS2, that sort of thing, they'll introduce some more control structures like switch statements, case statements, things like that. We're not going to get that far. Here, we're just trying to get you a basic understanding.
Do you teach this one?
I have not taught CS1 as of yet. I am capable of teaching it, but I am not currently on the list. I should teach it whenever you take it. I probably would only teach the lab. We have one professor that does the lecture, and then a bunch of us divide up the lab portion of it.
There's a lot.
It's like our Friday workshop, except I think you have 2 days a week lab now, and the lecture is held in one of the lecture halls. There'll be 100 students in it, potentially. All right. So syntax,
No, it's not.
syntax, if, condition, and then everything indented is what happens. All right, Keystone Cops on the front row. I'm gonna intermix you with the back row that, you know. Oh, yeah,
A question about before we get into this. Is there
Okay.
a break statement for Python?
so I'm sure there is, we're not gonna use it.
Okay.
So what he asked is if there was a break statement for the for loops, because in Java, you commonly see a break statement sometimes because you want the loop to stop.
If something happens.
If something happens, you want it to jump out of the loop. Yes, it definitely exists in Python. I'm not gonna spend a lot of time on it.
Is it still just break code?
I don't know, I'd have to look it up because I don't use it at all. I'm not a fan of break statements. If you're gonna randomly insert a break statement into a for loop, I don't think you've thought through your code very well. It's not, to me, good code. But other professors will have different opinions on that, but me, I'd rather you think through your code where you don't hate them.
It's just break.
It's just break. He looked it up, it's just break, you don't need the colon. Because it's loosey-goosey programming, you don't need any punctuation. All right. So remember, whatever your condition is, has to be something that you can think about as a true or false statement. It has to evaluate the true or false. So it's going to evaluate the condition. If it's true, it does the indented portion. If it's not true, it just jumps down to the next viable line. It could be an else statement, or it could just be the next line in your code. That's not indented. Indentations are important.
I love these, like,
All right, so if you haven't studied 10 hours, then study more before getting on Snapchat. I didn't write these examples, by the way. Study time is equal to get study time. If study time is less than 10, go study. If it's not, go play on Snapchat.
This is like a thing.
This one says that you're going to get to play on Snapchat either way because it's not an else. But before you can get to Snapchat, you have to go put in the amount of study time because it follows in order, right? I don't even have a Snapchat. I don't even know how it works.
Just this one's like it's funny. This like
I'm
like,
old. I use
Like,
Facebook.
yeah.
Yes. Look, I'm old enough to remember that you couldn't get a Facebook account without a college email address. You had to have a college email address to get your Facebook account because it was designed just for college students before Mark Zuckerberg sold it out. So, and whatever. I think he did use the same profile picture over and over again. All right. All right, so remember, if you have, the reason they call it branching is because you have the option of making several different steps in there. So it could take a different branch based on what the test is. Right? So if it is doing multiple things, it's gonna do them in order. So this is where that logical thinking in your brain has to work. So if we were doing the grade example, and we started with a C instead of an A, it wouldn't necessarily work. Because if you evaluated everything above a 70, then you're gonna get all your A's and your B's, right? So you have to be careful about the order you test things in, because sometimes it matters. And you also have to be really careful about not flipping your greater than and less than signs. It's really easy to put greater than in unit less than, and your brain kind of skims over that. So you might have to have, so this is not working, you might have to get one of your neighbors or me to look at it and go, oh, you probably missed this other sign because your brain missed it. So just be careful about that. So 2 branches here. This one doesn't give you the option, doesn't automatically let you go to Snapchat after you quit back and do the extra studying. You either have studied or you haven't. If you haven't studied, you're going to go study. If you have studied, you can go play on Snapchat. And then after you've done one of those 2 things, it's going to jump down and tell you to go to bed. But you're college students, you probably don't ever go to bed. College student living in my house, yes.
One problem thing with the statement, wouldn't it always tell you to use Snapchat before going to bed?
No. So you will use Snapchat only if it bypassed the study if condition.
Okay, so we'll always tell you to use Snapchat if you studied more than 10 hours and then go to bed.
Right. If you studied more than 10 hours, you can go play on Snapchat. Then you're going to bed.
Fair enough.
If you studied less than 10 hours, you're going to go figure out what study time you need to do, and then you're going to read your textbook. Then you're going to bed. You're skipping Snapchat.
Fair enough.
Huh? Based on this program, you're skipping Snapchat.
About my streaks.
Your streaks are just going to fail.
That is fail.
The only reason I know what a streak is because my son was complaining about his streak.
Did you have to restore it?
When we were on the cruise.
I thought it was that's exactly what happened to me. I lost 1,000-day streak on the cruise.
I lost that streak.
Because his mother's a cheapskate and didn't buy unlimited Wi-Fi on the boat. Honestly, I did it where they wouldn't make me work while I was on. All right, so you can have multiple if and else ifs, just like what I showed you for the ABC thing for your grade. You can do that for lots of different things. Honestly, you can carry on for a long time with ifs and else. I don't know that there's a limit. There's a limit to how much my brain will hold in that case. But just remember to be careful when you're doing else ifs, that you do them in the proper order, especially if they're building off of the same piece of data, like a grade. So this is what it looks like again for the grade one. There are other ways to do this. You actually can sandwich it in and where you're going, it's greater than this and less than this. And then the order doesn't matter because it's given it a range. We're going to talk about those in just a second. Y'all might want to pay attention that I had given you this example 3 times in the slides. There's a reason. Just let me point out, this example is going to come back again in your lab and your assignments. Remember, you can download these slides from Course 10 and you have them. So just be aware that I have given you this example 3 times for a reason. So let's talk about about Boolean expressions? So like I just said at the beginning of class, Boolean is a data type that stores true or false, 1 or 0 as an answer. It's a very small amount of space in memory, so it has its own data type to make it easier to store the 1 or the 0 than it is to store the word true or false. Takes up less space. So it always is used for those two things. You can't do anything else but true or false with it. So Boolean statements are things like, is age less than 21? That evaluates the true or false. You're either 21 and over or you're not. You finished with your homework. You either did your homework or you didn't. And don't give me the answer that my children always gave me through, I did most of it. No, you either done or you're not. Who cares if your dog ate it? Did you do it?
I did it when you gave that.
The computer doesn't care about what happens after that. It wants to know if you did it or you didn't do it. Computer is very logical. Money is greater than 500 and you paid your bills. So this actually is a multi-step thing. This and makes it have to evaluate more than one thing. So what it's going to do is it's going to evaluate 500 and paid bills first. If you got 500 and you paid your bills, that's going to come back as true or false. If that's true or false, it's then going to be evaluated with the money. I use parentheses around them to make sure that they evaluate the way I want them to. So and, or, and not are key words because you can use and or and not. It's part of your evaluation. My grade is a greater than 70 and less than 80. Both statements have to be true now. By connecting them with the and, both these statements have to be true for the whole line to be true. Now, grade is greater than 70 or it's less than 80. Either one of these statements can be true. And the whole line equates to true. Grade is not 59. Anything that's not 59 is true. If it's 59, it's false. Now, this is a truth table down here. We're not going to spend a lot of time on it. You will learn more about it if you are a computer science major or a math major, because truth tables come back in some of your math classes too, math theory classes, high level, discrete math kind of things. So not just negates it. Not just negates it. It's like putting a negative sign in front of a number. Makes it the opposite of what it is. If I say not true, that's false. Not false equals true. Right? Not 2 equals 3?
No.
No.
Negative 2.
So, and both sides have to be true for it to be true. Or one side or the other, or both sides, and it will be true. So if A is false and B is false, A and B is false, A or B is false. Because if everything's false, it's all false. If A is false, B is true, A and B is still false because they both have to be true for an and. But if it's an or statement, since one of them is true, the or statement is true. Yes.
Is it possible to have if not A or not B?
Yes, absolutely. What he was asking is if I could use not on either side of the comparison. Absolutely. I can use it on both sides of the comparison. it gets really confusing when you do a lot of that. So think it through carefully. You also can take a knot and spread it through parentheses. You know, like how you negate in math, you do negative and you parentheses and you have to spread it all the way through. There, you actually can do that with a knot also. And there's rules for it. We're not gonna cover them in here because we're not gonna do anything that complex. There's special symbols we're gonna use for Boolean operations. So remember I told you that all the math symbols were the same? With some exceptions. If you use two equal signs, that's comparison, not setting equal to. So if I need to see if 2 is equal to 3, I would use the 2 equal signs. So I'm comparing. Not is shown by an exclamation point. So exclamation point equal signs means not equal to. Not a factorial, it's a not sign. Or some of us old people in computer science will call it a bang. Don't ask me why, we just do. Less than, greater than, or the same. If you want less than or equal to, you combine a less than sign and an equal sign, or a greater than sign and an equal sign, because we can't draw that little line underneath it that we were taught in math. Does this make sense? The one that's gonna catch you regularly is the double equal sign. Because you're so used to writing x is equal to y, from math. So sometimes if you got something going wonky in a statement, check to make sure you did use the double equal sign. So these are some examples. A equals to 30 is not a Boolean expression, that's an assignment. Because I'm assigning 30 to A. Same with the B equal to 25, I'm assigning it. Loop is equal to true. I'm assigning the loop variable, the value of true, which you absolutely can do. So anyway, the top 5 are assignment statements. I'm setting whatever's on the left-hand side equal to what's on the right-hand side. The bottom portion down here, these evaluate to true and false. So if I did A is less than B inside of an if statement, it's going to return true or false. If A is less than, I get a true. If it's not, I get a false. I could then use loop also inside of an if statement. And it's going to come back and tell you what the value in loop is. And if it's true with a capital T like this, it's going to tell me it's true. Remember, capital letters indicate special things, right? Not loop means it's going to give me the opposite of whatever's in loop. So if it was true, now it's coming back as false. If I use a double equal sign, it's going to tell me if A is equal to B plus 5. It's not setting A equal, it's not setting A to B plus 5. It's going to compare the two and tell me if it's true or false. I'm not going to read all of these, but does that make sense? This I want to hit one of these down here at the bottom of the or. So if I have an or, an and or an or in the statement, it's going to do the math on either side first, and then put the two pieces together. That makes sense? So in this first case, it's going to evaluate if B is less than A first. If it is, then it will go on and finish the and statement. If B is not less than A, and it hits the and, it's going to go, oh, I don't have to check the other side because I've already got a false. So it won't check the other side of the and. Just keeps the computer moving a little faster. Now, in the case of an or, it has to check because only one side has to be true. That makes sense? We're not going to do the task. So It's a really short slide deck. But it's an important concept. Do we have any questions? So you can now use the rest of the time in here to work on project one, because it's not due till Friday. Or if you've got it all done and you don't have any questions for me, you're welcome to go ahead and exit class. Up to you, you're big people, make your own decisions.